Okay. So yesterday we are still in the polynomials, and I think today we also still in the polynomials, and next week maybe if we finished all the polynomials, next week we'll move to the next chapter, which is the exponential and logarithmic. Um, okay, to recap our yesterday class. So yesterday we are moving from this part. Okay, so if you see from the polynomial functions here, it has x minus 2, x minus 3, x plus 4. We can get easily the roots, or we call in the polynomial section, it's called the zeros. Okay, so x is equal to, x equal 3, x equal -4. That's our zeros. Okay. And all zeros here of the polynomial functions, they are all factors of a constant. Okay. And when you expand the form, okay, what you need uh, to look at is the first terms here, the first constant here, and the last terms. Okay, see the constant. Okay, so here is 1, and the last terms will be 24. Okay, and why it's important, because we can see when you have the polynomials where your first term is not 0 and the last term is also not 0, you will have this ratio. So every rational zero of the polynomial functions is the form of this p over q. What is p? What is q? P is the factor of constant a naught or the first terms, okay, or the last term, sorry, and the q is the factor of the constant a n here. So if you see here, okay, 24 over 1. Okay, so 24 over 1 meaning factor of 24. We can get a lot of number from here. We can get 2, 3, 4, actually 1, 2, 3, 4, maybe 6, maybe 8, 12, right? And so on and so forth. You check every possible number of the zeros, and eventually you will get this as a result. We went to for some examples like this one. You get 2 as the last terms and 1. Okay. So factor of 2 and 1, because 2 is only having two factors, 2 and 1. Okay. So we only care to test this plus minus 2, plus minus 1. Okay. We test the number because it's not really that much number. It's only 1 and 2. We can get easily whenever they get 0, then that is our option. Okay. So this is plus 1, and the other one is -2, and we get the answer like this. Okay. So first, when you are trying to find this rational zero through this p over q, first you can list all possible zeros. Okay. You can test. Okay. You can plug in the function if the function is easy enough to calculate, or you can divide by polynomial long division or synthetic division, and repeat until you get the results. Okay. So basically, that is the how to find rational zeros with the p over q. And the other part, like this one, this is the same examples, I think. Maybe here we get 6, and this is 2 here. Okay. So factor of 6 divided by factor of 2. So factor of 6, we have 4 different number. Factor of 2, we have 2 different number. Okay, and we divide 6 by 2. So 1 and 1, 1 over 1, 2 over 1, 3 over 1, 6 over 1, and then 1 over 2, 2 over 2, 3 over 2, 6 over 2. Because 2 over 2 is the same thing as 1 over 1, and 6 over 2 is the same thing as 3 over 1. We can cancel this out, and we have at least this number to test. Okay, we can check the number, testing the number. If it's easy enough to calculate like 1 and -1, we can check, but unfortunately, it's not our answer here. So we need to try another number. We try 2. Let's just divide by syntactic divisions, and you got it's 0 here. That's why our number 2 here is our zeros. Okay. And then we can also check this part. Okay, this 2x squared plus 5x negative 3. Okay, if this expression is easy to factorize, then just factorize. Okay, but if you feel, maybe if you get the questions in the exam, you feel nervous, you feel not sure is it correct or no, then just divide with another number. Use syntactic division, and when you get zeros, oh, that's my number, and you will get the last part here is just 2x minus 1. So from here you can get easily the solution is x equal half, the last part here. So the zeros are negative 3, half, and 2. Okay, I think that's easy enough. Let me go one more time. Okay. I have a polynomial with degree 4. Okay, find rational zeros, or find real zeros here. Okay. I give you maybe 2-3 minutes to try and solve. See if you are familiar with the method. Okay. Okay. So x to the fourth minus 2x cubed minus 7x squared plus 8x plus 12. Okay. First thing is see the last term and the first terms. Okay. The constant on the last term and the first term. See the possible number of zeros from the P and Q. Let's start from the last terms. So P over Q is factor of 12 over factor of 1. Okay. We can see from 12 here, 12, you get the what number that can make 12. So 1 multiplied by 12, right? 2 and 6, right? And 3 and 4. Anything else? No, right? Just these 3, right? So we have 6 number here, which means our possible, let me write this as possible zeros, is plus minus 1 over plus minus 1. It's P over Q. Remember, you need to divide by the Q. And then 2 plus minus 2 over plus minus 1. But because it's all 1, then let's just write the results, okay, directly. Plus minus 3, 4, 6, and 12. Okay. Okay, and then what? If it's easy enough to plug in the number, then just plug in the number like 1 and -1. I think that's easy enough to check. So let's try 1. 1, 2, 7, 8, 12. With 9, -1. I think it will be not 0, right? Do not really care much what it is, but it's not 0, right? And then plug in -1. It's become positive, become negative, negative plus 2, positive, negative, uh, -5, 4, -12 plus 12 is 0, right? Right? So this is our zeros, okay? But then, because it's polynomial degree 4, if you want to try 2, 3, 4, and calculate, that's up to you, but I don't want to do that, so just make a division. So 1, -2, -7, 8, 12. Okay, let's divide this by -1 because we know that it's our zeros. So 1, -1, -3, 3, -4, 4, 12, -12, 0. Okay. Okay. So this is 0, and this is our result from the division. Okay. So this is still x cubed, x squared, x, and 12, right? This is x cubed, x squared, x, and this is the constant. So it's still having a cube. I think it's still, because if you want to calculate, that's up to you. But for me, I'm too lazy to calculate, so let's just divide one more time. Maybe try the next number, maybe 2 or -2. Let's try just 2. Oh, yay. We got 0 here. So 2 is also our zeros. 2 is also our zeros. And then we have, this is x squared minus x minus 6. Can you factorize? I think we can factorize, right? It's x minus 3x plus 2. Okay. So all the real zeros is -2, -1, and 2, and 3. Right? Okay. If you still doesn't have any clue from the very beginning of these questions, um, you need to have a lot of, I don't know, maybe read the previous chapters. Okay, I think that's not too difficult. Okay, next, let me get one more, and then from this I will explore more what we can do. It's similar. It seems similar, but it's different at several constants. Okay, so find real zeros here. Again, say the constant. It's 8 and 1. Okay, because it's only 1 at the first term, so we just need to care about the factor of 8. I think 8 is only 4. 1 multiplied by 8, 2 by 4. Yeah. Okay. Mhm, mhm. Mhm. Okay, some of you already try putting 1 and -1. I think 1 is not right, not 0, right? The possible zeros is, okay. Then uh, we can pass the number, which is not 0. This is also, it's not 0 also. So it's 2, 4, 8. Okay, let's try 2. Let me just use the syntactic division. Okay, it's our zeros. So we can write dpx as x -2, x cubed -2x plus 4. Okay, from this second, maybe let's try the -2. So 1, 0, -2, 4. So it will be 1, 4, 2, -4. Oh, yeah, it's also our zeros. So I get the x minus 2, x plus 2, um, x squared minus 2x plus 2. Okay. Okay, can you find other zeros? Okay, we got until here. We got until here. Can you find another zero from this part? No, there is a zero, but it's not real. Okay, we say that it's imaginary. Okay, and that's why we need to include imaginary. Okay, so the next section will be including imaginary in our calculations. Okay, so we say that this part is irreducible quadratics. It's imaginary because if you draw the graph, it's not having any roots, right? If you draw, okay, the easiest way to draw is changing the form into this form. So this, let me check this one. So this is 2x plus 1, right? So you need just the plus 1, right? It's called the complete form of our quadratics. Okay, it's really simple. It's really simple method, but when you use that, like in this quadratics, you will get easily what is happening to the shape of the functions. Okay, so the functions is just the same shape as x squared, just like ordinary x squared, just like that. You move to right 1 point, move to up 1 point, right? Okay. When you see the graph, it's not having any intercept at x, right? It's not crossing the x-axis because it's moving to the right and and up. So it's like above the x. That's why it doesn't have any roots. Okay. Okay. And then how to find how many possible imaginary roots? Okay. There's another method. Um, we call the rule of signs. Okay. Rule of signs. Okay. So that's how we will go into the next theorem. I will write the name of the formula. It's called Descartes rule of signs. Okay. I will write the words first. Okay. Number of positive real zeros of polynomial x. Okay. Either is equal to number of variation in sign in sign in px, or less than that by an even whole number. It seems too many words, but actually it's pretty easy. And the second point, okay, number of change the positive into negative, okay, and all change the px into p negative x. It's the same, and change the p to negative x, okay. And the words are the same. The words are the same, just changing the negative, positive to negative, and x to negative x. Okay. Okay. So with this Descartes rule of signs, okay, you can get how many zeros. How many zeros? So you need to try first is the positive x, and the second try the negative x. Okay. How to how to um, how to do this rule of signs? Signs means just positive, negative, positive. You have like x squared plus 2x minus 1, right? You have the positive sign and negative sign. So for example, okay, let me just give you right color. Px is 5, and then plus 2x squared plus x minus 3. Okay, this is just the px. Okay, so look at the positive, negative, negative, positive, positive, negative. Okay, how many times does the sign changing? Okay, okay. This is positive going here is negative. Okay, so this is one time changing. Okay, and then negative, and then to positive. Okay, second time, and then from positive to negative. So 3 times. 3 times it's changing. Okay, so the words is saying that okay, the number of the positive real zeros. So first, this is the positive real zeros of the px is equal to the number of variation in sign in px. So 1, 2, 3. So it's possible to have 3 positive zeros, but it's not concluded yet. It's just our um, predictions. Okay, it's just a prediction. So 3 possible zeros, or less than that by an even whole number. So what is even number? 2, 4, right? So this is 3. So what's the last even number than 3? 2. So 3 minus 2, 1. So it has possible 3 positive zeros or 1 positive zeros. Okay. It can be possible. It can possible. Okay. And then try the negative x. So we're changing the x here to negative and plug in the negative here. What will happen? It will be negative 5, right? And then it's also changing here. It's still the same. And it's still the same. Changing here, it's still the same. Well, let me make it bigger here. So it will be changing here. 1, 2, 3, 4. So it's 4. So you can write. We have. Let me just make it move to here. So we have 4 negative zeros or 2 negative zeros or 0. There is no negative zeros. Okay. Okay, let me give you another example, which much more lower degree than 7. I think 7 is too much. Uh, because it's related to how many zeros we will get the number. Okay, I will try with the lowering the degree. Yeah. So if you find zeros, it can be like, for example, x minus 2, x plus 1. It has negative 1 and plus 2, right? Your zeros. So negative mean negative number. Positive mean positive. So it's saying that you will have 3 positive number of zero. So your zeros will be positive 3 number or 1 number. It's possibility. For negative, it can be 4, it can be 2. I think it's not 0. Yeah, I think it's only 4 and 2. Okay. Because the idea of this degree 7, your positive and negative or all the zeros that you have, the the all the total zeros should be equal to 7. So for example, maybe it has 3, 4. But what about 1? It can be 1, 4. It's 5, right? You still have 2. Maybe 2 is imaginary. That's how you find how many imaginary you have. Okay. Yeah, this is just a prediction. Then after this, we need to plug into either you test the zeros and then you put into the table, just assuming how many number of imaginary we have. Okay, so this is not really useful for finding the real zeros, but it will be useful for at least you have the list of possible zeros, and you will have how many imaginary number here, because sometimes your polynomial you cannot really grasp how many imaginary they have. Okay. Okay. Let me give you lowering the degree so we can think more clearly. Okay, I think 7 is too high. Let us lowering the polynomial. Okay, x cubed. I think this is better. Okay, first with the method of the Descartes rule, we see the changing of signs from here is 1, right? And the other one is here, so it's only 2. Okay, so we will have 2 positive zeros or less than uh, an even whole number. Okay, so 2 minus 2 is 0, or there is no zeros at all. And then we plug in the negative x. Okay, so negative here it's only 1, right? So it's only having one negative zeros, but it's already one. There is not any even number less than one, right? If you 1 minus 2 is negative, right? Um, it's not in our definitions. So it's just having one negative zeros, possible, okay, possible. And then we can draw, okay. For example, draw the table. This is positive 0. This is negative 0. This is the. Let me draw one more. Okay. And this is total, and this is your imaginary here. So first you have 2, and you have 1 negative, and your imaginary will be 0. Total is 3. So the total 3 is depend on this degree. Okay, how many degree? Okay, and the other one, the possibility is 0, and because there's only still 1, then it's just 1. Okay, then it's turn out the total should be 3, so you have 2 imaginary. Okay, and we can try to test whether this prediction is correct, and we can find the real zeros. Okay, so this is the Descartes rule first, and then 2, try to find real zeros. So let me write the functions. X cubed you can try to because it's just 2 and 1. You can have the factor of 2. So it's just plus 1 and plus minus 2, right? It's only 2. So you can try F1. Yeah, 0. So you have 1. Yeah. So you have x minus 1, x squared minus 1 minus x. Sorry. And can you factorize this one? X minus 2, x plus 1. Okay, I got all the zeros. So let's see. Okay, x is 1 and 2, and x also is negative 1. So 2 positive 0 and 1 negative 0. This possible root. Okay, so this is the correct. So it depends on how the problem will asking. If the problem asking like list all the possible root for the zeros, so you need to find all this root, okay, and then check whether which root is correct, okay? And then you need to find the real zeros, and you get the 2 positive and 1 negative. So this is your root, okay. Okay, any questions first? Any questions? Have you learned this before? No. No. Okay. I also never learned this before because I think most of the problem in algebra, calculus, they all um, not really going to, because there is a difference with applied math and scientific math or pure math. It's quite different. Applied math is close to engineering problems. Okay, they solved by, for example, um, you don't really care what really happens in the um, in the object. Okay, but engineers, they try to recreate and reiterate, approximate that's engineers. Okay, and I think most of the courses you will have in NTUFT, it will be more like it's closer to having real life situations, like in industry related to your department. There will be several parts that, okay, you will use math, but it's more like applied math. Okay? But this part, like this Descartes rule, I believe this is more like to pure math. Okay, so you so if you just need to find, okay, finding the roots in the graphs, then you can just find the roots, right? You don't need to have how many roots they have, how many imaginary numbers they have, right? But at least in this basic math, I'm just showing you that you can also having this approach, okay, to see whether we can prove that, oh, actually there might be a possibility that the number will be imaginary. Okay. Yes. Mhm. This one. Mhm. Okay. Two. Yeah. 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 Okay. So first, okay, possible number for positive is 2 and 0, right? Okay, you write 2 and 0. Okay. Possible number of negative is only 1. So in all case, it's only one possible negative 0. So negative 0, 1, 1. 2 plus 1, 3. And 3 is our definition of the polynomial degree. I think we had like in the early courses that uh, the degree will state the how many zeros we have. Okay, so we have 3. So this root should have the total 3, and that's how we get to 3 minus 1 is 2. Okay, let's try some examples. Try to make it familiar. But before that, for the online students, do you have any questions? Any questions, online student? Or any questions from you guys? Hey, um, let me write x cubed um, find how many possible root for the real and imaginary zeros, if any, and find the correct root. Okay, can you try this one? So first, finding the possible root, meaning you need to find all the possibility, okay, using the Descartes rule. And then second, find the correct one. So you need to test which one is the correct one. Maybe we have one or two examples, and then we can go for um, the other sections, and I think we can finish if we have time. So it's x cubed. It's x cubed negative 6x squared plus 13x minus 10. So to write the answer, you can start by using the Descartes rule, or you can start by the integer p and q, and then Descartes rule, and then maybe finding or confirming which zeros are correct. You can have many ways. Okay, we can start look the last and the first term. Uh, Writing the p over q. is factor of 10, factor of 1. Then we can write the 10, 5, 2, and also 1. So this is our possible zeros for the real number. Okay, and then we can check uh, the positive zeros and negative zeros. Okay, so for positive, we have 1 here, and 2, and 3. So we will have 3 positive 0 or 1 positive 0. And for negative zeros, there is no variation. So it will be 0 for negative zeros. So we will not have any negative 0 at all. It's 0 possibility. So positive, negative, imagine, or I'll just write I. Okay, imaginary. The total should be 3. Okay, so first is 3, it's 0 and 0. Okay. Second one is 1, 0, and should be 3, so it's 2. The next part is checking which root will be correct. So we test our zeros. Test. So here's the thing. One of the benefit using the Descartes rule, because you will not have any negative, so you can test positive number only. Okay, so you remove the negative because it's not possible. Okay, so check the 1. I think it's not, right? It's not 0. And check 2, maybe just use synthetic division. So 1, negative 6, plus 13, negative 10. And divide by checking 2. 9. Is it correct? Oh, it should be 6. Oh, wait. I made mistake. It should be 1 to negative 4, negative 8. Okay. 8 zeros. So you can have our f of x is x minus 2 and x squared. Okay. So from here, I will write my equation to be something like this. So first of all, it's quadratic functions. It should be easily to be factorized, unless it's not, right? Can we factorize this one? X. No, right? No, right? No. Okay. Then this is also our, or if you want to find the what is the it should be x squared minus 4x plus 4. So to be 5, so it should be plus 1. So it's the old x squared, just the regular x squared, but you move the graph above. That's why it doesn't have any real roots. This is having imaginary. How to find the imaginary? To find the imaginary, you need just to use the quadratic formula. So 4 plus minus 16 minus 4, 5, 20, 20. Is that it? 20, right? Yeah. 16 minus 20 is negative, right? So that's why it's imaginary. Okay. So let's finish this part. Divide by 2. So I will get 2 plus minus it's half, and I will write 1 by 1, so you get the idea. So if you have negative 4 like this one, okay, you can write this. First is 4 square root of 4 is 2, right? So 2 going out, and inside it still have negative 1. We are defining this negative 1 as I. Okay? I think I mentioned in the early classes about numbers. Okay, so you can write this. So you can have 2 plus minus, because it's divided by 2, so half, so it's 2 plus minus I. So we have 2 plus I, and we have 2 minus I. So that's why these roots are correct. We have one positive zeros, which is 2, and we have the other imaginary zeros. So this is the positive one. This is the imaginary. So this is our zeros. Okay, 1 real zeros, 2 imaginary zeros. Okay, do you want more examples, or we go to the next session? More? Okay. Okay, give you one or two examples. That's the functions or the polynomial. X cubed minus x squared minus 4x minus x minus 6. The same question as previous. Find all possible root for all zeros. Find real zeros and complex zeros if you find. Okay. If not, just the real zeros. That also fine. Okay. But if any complex, you find. Okay. So let's just take. I will give you a couple minutes, maybe 5 to 10 minutes to try. And then after this, we go to a little bit uh, new content, still in polynomial. Um, and then the last part, I will give you some um, questions. You still can follow the course. It's okay. Also, where is where's the place for your quarantine? Okay, so you go there like alone, or other students go also nearby? Okay. Okay, anyone finish? Okay. I think finding the rule of signs is not too difficult. So you see from the positive x is only one variation, so only one changing. And from the negative x, you see it's two variations. So this has one positive zeros and two negative zeros, or zero negative zeros. And you can put in all the possibility, a positive, okay. So this is the roots that you will have. Okay, you have two possible roots here. You can have one positive zeros or and two negative zeros, or you can have one positive zeros or two imaginary. Okay, because uh, it's having exactly one positive zero at all possible roots. So we can check all positive zeros from the our p over q integers. Okay. So from here is negative 6. It's 6 and 1. So factor of 6 is 1, 2, 3, and 6, right? Factor of 1 is only 1. So we can only care about this 4 number. So we can check the positive number. We can check 1. I think it's not, right? Let's just check the syntactic division. It's also not 0. Okay. Let's just change to other positive number. 3. Okay, I think we got the 0 here. Okay. We got the zeros is x equal 3. So our f of x will be x minus 3, and then x squared plus 2x plus 2. Okay, so we have the quadratic function. So check whether we can factorize. I think we cannot factorize, right? We cannot factorize, so it's irreducible. Irreducible, and we can just using the, so it should be imaginary. So for imaginary, using quadratic formula. So we have -1 plus minus square root of -4/2. It will be -1 plus minus I. Okay. So you have -1 plus I and -1, -I. So in fact, your root will be the second one. So 1 positive zeros and 2 imaginary zeros. So your zeros, the real zeros are x equal 3. The complex zeros is x equal okay. Any questions? Okay. Uh, Let me go through a new session. Okay. It's called the upper and lower bounds in polynomial. Maybe just a 5 minutes explanations, and we will continue the explanation the next week. And I will give you some examples. Okay. Okay. So upper and lower bounds. Upper and lower bounds is any x that when you plug in, it can be an upper bound or lower bounds. And we need to have some definition to how we distinguish the upper and lower bounds. So I will just go for example first. Okay, this is px. Let me just go for, okay, 2x cubed plus 5x squared plus x minus 2. Okay, let's say I have a is -3 and b is 1. So this is a number that I choose. Okay, let's check whether -3 or 1 is upper or lower bounds. Okay, so I will give you the how it works first, and then I will give you the definition later. So first, we are using just syntactic divisions: 2, 5, 1, and -2. Okay, and we check the uh, we check here -3. Okay, so this is 2, -6, -1, 3, 4. It's -12, so it will be -14. Okay, this is the first one, and second one I will check the b equal 1. It's 1, it's 2, it's 7, 7, 8, 8, and it's positive. Okay, positive 6. Okay, so from the first case and the second case, okay, when you divide -3 and you divide this with 1, the results, okay, you see the results. Okay, the result from this second one, you see all positive. Okay, the result from the first case is positive, negative, positive, negative. Okay, by definitions, okay, the first case is lower bounds. The second case is upper bounds. So, okay, A is lower bounds, and B is upper bounds, both for zeros of polynomial. If real zeros C of our polynomial satisfy A less than C less than B. Okay. So when you find any number and you find it's all positive or it's all something sign, which means you have upper and lower bounds. And your real zeros is in between of these two. Okay, I think I will continue the upper and lower into the next Tuesday's class. And I think the next Tuesday's class will be the last part of our polynomial. I will give you another question to see if you understand what we have done in the last week and maybe 2 weeks ago. Okay, have you done writing? Okay. Let me go for some okay. Uh, Solve for x. Let uh, it is just to remind you. Okay. I think 1 or 2 weeks ago we have also inequality, and I want to see how you are doing after that questions. Do you still get the idea or still confused? I believe it's rather complicated, but you need to try solve it. If you find the solution, raise your hand. Okay, I will give you a bonus point and some snacks. And then perhaps another snacks will be when we have the quiz and maybe the final, or maybe just the quiz because the final is the last day of the class. Solve the inequality. Okay. Actually, the inequality in rational function should be uh, as like the last session of the polynomials, but I give you in the first early chapters because I think it's really important because you will see this situation of the inequality more and more in calculus, maybe in engineering math, and if you don't understand the concept of the inequality, the basic one, if you don't understand, you will have difficulty in all the next math courses, calculus, and so forth. Okay, try to solve. Okay, the online students, you can also try to solve. Finish. Have you checked? Okay. 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 It is squared. Y is here. Mhm. But I think you're. Oh, wait. Yeah, the rest is okay. Yeah, maybe some. Yeah, some. Yeah. Yeah, but because of this, right? So yeah. Lost Y. Yeah, you can check like one by one the number of the equation. But I think you need to solve it anyway. Either you move from left to right or right to left. Yeah, continue. Yeah, you can try all the numbers you can think of, but I don't know if you can find those numbers or not. Yeah, it's also possible you're trying like trial and error. Uh, if you try to find the x by trial and error, like x equals 0, x equals 1, 2, you can do it. But in this case, you will not find the specific answers. But if you have an exam, those exam is in multiple choices that you can do. That is one trick that I learned in high school. When you have a multiple choices exam, rather than solving the question directly, if you have the answer, you just check whether it's correct or not. And in high school, I always bring my ruler into my exam, because usually if you have like geometry problem, the scaling will be perfect. So you will have an exact answer if you need to find the geometry. It, yeah, maybe you don't need like the calculator, but you just need the ruler, especially the ruler with the angle. It's faster to find rather than using the formula. Yeah, just trick that I learned through my high school. Fine, confused, right? Remember, if you find a rational inequality, always using the line number and making the top and bottom as just normal functions. Mm-hmm. Almost. Yeah, almost. But uh, your calculation, this is the process is correct, but the conclusion is almost. Okay. The idea of the inequality is you need to have your function or this, right? You need to have this to solve, right? Regular functions is just like finding roots or etc. Is just equaling 0, right? But inequality, it's either greater, equal, or just greater, or just less, or less equal. And this is the inequality. So when you see this, you can solve, right? You can find the x. Depends on the function. If the quadratic, you can factorize and you can find the x. But here, you have in the left side, you have some rational, messy, right? And in the other side, you have the square root of x minus 1, quite messy, right? So either you can move this to here or here, move here, right? And then try to find in any way you can algebraically simplify the equations. Okay? Mm-hmm. Yeah. Have I put something in the Moodle? Really? The PDF files? Have I post all the notes, right? Okay. Okay. I will check. I have prepared some PDF files for the exercise. Yeah. Okay. I was still waiting. Okay. Okay. How you find 0? Okay. 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 Good. You're still struggling. Yeah, you can get something here. Should be not. X should be what? 1/3, right? Yeah, you just stop here and just line number. Okay. I think there are 2 students who solve, 3, but I think from 3, 2 is correct. The other one almost correct. Let me just give you the full explanations. Okay. So first, can I say this? Um, see the equations first. Okay. So you have this part, rational functions. Okay. Like I mentioned before. Okay. Never multiply this to here. Don't do it. Okay. Because what? Because of this part is important. Why? Because this is your original function, and this part, when you plug in something, it should be restricted, right? You cannot plug in 0, right? Okay, that's one thing. Okay, so my suggestion is just going from here to here, and we can write this. Okay, and what you can do from here, let's just make the bottom square root of x. Okay, this also. Then we can have square root of x. Okay, we have all this squared minus square root of x. Square root of x has become 4x, right? X minus 1 greater equal 0. Okay, maybe solve this part first. Okay, it's not too complicated. It's just quadratic expansion. Solve with this one. I think we get this x squared, x, right? Solve that. We get this expression. It can be factorized. Can be factorized easily. 3, 1. So 3x plus 1 and negative x plus 1. So let me get to here. So when you have this part and this part, you can go for a line number if you want. Did I draw? Yeah, this is my line number here. So from this line number, treat all this just like regular functions. So we have x is negative 3, x is 1, right? X is 1, or x is 0 from here. Okay, put all together in the line number and check the number. Maybe check the number between, check number last, check number greater than 1. Find the positive one that greater than 0. Check the number. Check the number. Okay. And then because your domain here, it needs to be greater than 0, right? It needs to be greater than 0. Your domain. Okay. So in this part, it should not be. It should not have any negative, right? So when we plug in negative 1/3, it will undefined in this case. Okay, yeah, it's imaginary, but in this case, it's undefined. It's not real. Okay, so we are only concerned about the positive one. So that's why our conclusion, based on how we get all the solution for x, we include also the domain, and we get the result is only here. So from the 0, but it's not 0, so greater than 0, and 1, and close interval. Okay. Okay. I think Watson correct and faster than. Oh, so congratulations. Okay, and I also will note your contributions to the points. Maybe I will make the points for quiz or exam. Let's see, but I will count that as a bonus. You will have also bonus, okay, but not snacks. Okay, so, okay. Okay, any questions? Any questions? I will finish this today. Finish under here. I hope. Okay, I hope you remember about domain. Okay, and also range. But I think domain is more important because before range you need to also consider domain because range depends on domain. Okay? So domain will be also discussed in calculus, okay? Because it's really basic. Okay? So for domain, there are 3 cases that really important. You have rational, you have square root, the second one, And the third one, if you have log. Okay? That's three cases that you need to be considered when you are discussing domain in functions. Okay? If you have just rational here is not equal 0. But if you have the square root, then it should be greater than 0. It cannot be half negative. Okay? To be real, to have a real number inside. And you have log. Log should be greater than 0. Okay? Okay. I think that's it for today. So thank you for. Uh, okay. So sorry, I just see your answer. Okay. 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 Wait a moment. Okay. So if you need the QR code, here's the QR code. Probably wait maybe 1-2 minutes for you to scan. The class finished. Good student. Good student. Good student. Because when I was undergrad, I'm not that typical student who like read the textbook, write the notes. I was quite lazy that time, so don't follow that step. It was at that time. It was like, oh, I'm just trying because I was bored in my office. But I was working before, and I was bored, really bored. It's like you do it everything the same thing, like, oh, you blah, 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 blah. So I decided to talk to my previous advisor in my undergrad, and then that in that time, Taiwan Tech are like they are visiting some countries and they are presenting, but I'm not present in that presentation. So my advisor he present and, oh, you can talk to this man, email him, blah blah blah, and then I got here, and then when I finished my master, then I was thinking, oh, maybe doing my PhD, and then that's why I'm here. Yeah, you're welcome. Yeah, if you ready scan, you can go home. Or if you have another course